Hey guys, today we're going to take a look at what we call interpolation and extrapolation. So these are both methods of making predictions based on data. The first type, interpolation, is when we are making a prediction that is inside the data set. Inside the data. Usually, if we're interpolating, it's very, well, maybe not very, but it's pretty accurate. Accurate. And that's because we're kind of making guesses within what we have, okay? Whoops. So you are interpolating when the value we're finding is somewhere between the first point and the last point, okay? Extrapolating, which is our hint here, tells us that it's when we're predicting a value before the first point or after the last point. So this is when you are making a prediction outside of the data. Outside. There we go. It often requires that what you do is extend the line. Extend, and this is referring to the line of best fit or the trend line. Okay, so here we have a chart here. So this table shows the number of paid admissions to the movies in Canada for 12-month periods ending in March 31st. Okay, so we're going to graph this. Before I start, though, there's a couple things we need to do. First of all, we need to decide which of these two variables is the independent and which one is the dependent variable. Okay, this is something that we often will make mistakes on. So remember, the one that affects the other one is called the independent variable. Anytime you have time as a variable, it's going to be the independent or the x, because you cannot affect time. Time affects variables. So the attendance will be our dependent variable because the attendance will depend on what the year is. Okay. The other thing that I want to mention that we kind of glossed over, and it did come up in some of the work, is the difference between what we call discrete variables and continuous variables. So this first variable here, this year, is called discrete. Discrete, sorry, just ignore that. Discrete variable, and then this one is called continuous. And the reason for that is if you have a discrete variable, it means that you have set amounts that you have to choose from. So there's no such thing as 1995.2, okay? I mean, you can sort of make up what that means, but it doesn't really mean that. It's either 1995 or it's 1996. It's not 1995.2. The attendance, on the other hand, is continuous here the way we've written it because it's got these decimals, okay? I mean, you could actually argue that the attendance is also discrete because you can't have part of a person, but we've written it out kind of as if it is a continuous variable, okay? And that's because it has these decimals, all right? So what we're going to do is we're going to graph this data. Actually, the more I think about it, I'm changing my mind. You know what? That is absolutely a discrete variable. That's also discrete. Okay, you can't have part of a person. I'm changing my mind. There we go. I'm calling that one discrete. All right, anyway, we are going to graph that data on this chart here. So I'm just going to use my magic. And there we go. There's our data all graphed out. Okay. So the first question we have about this is to describe the trend. Okay. So it's fairly obvious, but in case it wasn't obvious, there we have ourselves a trend line. It's not drawn very well. It's very difficult to draw this on a tablet, but fill in the gaps there a little bit better. There we go. Okay. So there's our trend line, and it does clearly show that this data is an increasing trend. Okay, so that's an increasing trend. Okay? So the question we have is, what would the movie attendance be approximately in 2001? So in 2001, it did not give us the data. So what we do is once we've drawn a line of best fit, or once we've drawn this trend line, we're going to just look at where the trend line is. And when it was at 2001, it was about right there. Okay? So I would estimate based on that it was approximately, and that's what that little squiggle means, is approximately 119 million. Okay? So that's called interpolation there. So that's our interpolation. Interpolation. And the reason it is interpolation, of course, is that that point lies within the data set. My data set goes from 1994 all the way up to 2003. Okay? So because I have, I'm looking within that time period, that's interpolation because it's inside that time period. And we can estimate that that's probably fairly accurate, to be honest. It might be a little higher, a little lower, but it's not going to be drastically different probably because there is a clear trend at that point. Okay, so then the next question is, and I did make a typo. This here is supposed to say 2004, so you can just change that to 2004. So we're going to estimate the movie attendance for the year 2004. Okay, so if we look at our trend line, now our data stopped at 2003, so we're now doing what's called extrapolation. So this one's extrapolation. Because we're now looking at a place outside of the data set. My data only went up to 2003. I'm looking at numbers beyond that. Okay, it would also be extrapolation if I asked, for instance, what I would have thought in 1990. Okay, because that was much before, or that was before the data set. Okay, but if we do look at this trend line, we can see here that it's probably, if we look at our trend line, it's about right there, and so that's about 133 million. Okay, and so this could be wrong, but that doesn't matter. That's not the point. We're looking at the data and we're making an estimate based on the data that we have. Okay, and that's what it means to extrapolate or interpolate. Okay, that's all for this time. Until next time, go Sabres.